regarding quantum mechanics, what we will be reading in quantum mechanics, basically the de Broglie hypothesis. We will be studying the Heisenberg uncertainty principle. We will be studying Schrodinger equation, one dimension and three dimension, and potential in a box. The main five things we will be doing. So I will try to complete this one within 3 classes. Let's see whether we can do it or not. Okay, so tomorrow we will be having one more class. Okay, tomorrow the same timing at 8:15, 8:20. There will be a combined class. আমি এখন এখানেই বলে দিলাম. So I will be giving you the ID only. I'm writing nothing. ID and password, and you will join accordingly. Okay, tomorrow again from 8:15 or 8:20 we will have a class. Okay, now let's start it. Hold on. One second. Hold on. দাঁড়াও, আমি পিপিটি থেকে পড়াবো। আমরা শাড়িঘাট থেকে গেছিলাম, কালীমাই গেছিলাম, 7টা হ্যাঁ হ্যাঁ ঠিক আছে, আমার সাথে কথা বলে Is it visible?
Yes, sir.
Yes, sir.
Yes, sir. সুভাষিস পরশুদিন করবি ক্লাসটা? কি পাঠাবো? 1 মিনিট হোল্ড কর। তোকে রেফারেন্স দিতে বলবে, নাহলে বুঝবে না। হ্যাঁ, এই রিসেন্টলি, হ্যাঁ 19 তারিখে গেছিল। ওকে, ফাইন। Hope this is visible. Visible?
Yes, sir.
ঠিক আছে। So okay, fine. We will start quantum mechanics. Okay, basically first of all, যে ব্যাচে আমি পড়াই সেই ব্যাচে আমি অলরেডি বলেছি তারা একটু জানে। শুধু F3 F4 তোরা জানিস না, আমি ক্লাস নিই না। Basically first of all we should try to understand why we are studying this quantum mechanics. Okay, why we are studying. Suppose if you are talking about an atom, okay, and you are talking about an atom, and what happens is over there we know the electrons are moving around the nucleus, right? So again, according to classical electromagnetic theory, if a charged particle is moving, then obviously it will radiate energy. And if that is so, then the electron which is moving around the nucleus should radiate energy. And in that case, its radius of the orbit would start decreasing. At one point of time, it will just fall onto the nucleus and the atom will collapse. But that doesn't happen, we know. So, while the scientists are studying all these phenomena and trying to explain all this at that point of time, say in 1800, late 1800 till 1900, 1902, they were able to explain all those phenomena in terms of classical mechanics. Okay, so but then comes some phenomena which cannot be explained by classical mechanics. So that means obviously there is some other type of explanation or mechanics lying underneath this phenomenon. So basically what happens is when we are going to the lower dimension, when we are going to the atomic scale, when we are talking about the atomic particles, the electrons, protons, neutrons, classical mechanics is not able to be used for explaining different types of phenomena, and hence quantum mechanics evolved. So can anyone tell me what is the origin of quantum mechanics, if we want to say? What is the origin? Anyone in class? What is the origin of quantum mechanics? If I ask you, what is the origin of quantum mechanics, what will be your answer?
Sir, Planck's constant.
Devolli?
Dipchit.
Yes. Hold on. Planck's hypothesis is the origin of quantum mechanics. Max Planck, he just gave famous hypothesis that whenever energy is absorbed, radiated, that is in terms of quantum, right? He was talking about electromagnetic radiation, and over there, he just put this hypothesis, right? We cannot get energy, a continuous spectrum, we cannot get. And this energy is measured in terms of E equals to h nu, and where h is said to be the Planck constant. And that is the origin of quantum mechanics. Using that phenomenon only, Einstein formulated his photoelectric effect using hypothesis equals to h nu. And Einstein got the Nobel Prize for this one, not for special theory of relativity, obviously for this photoelectric effect. That was the origin of quantum mechanics. But for a long time, it was dormant because there was no such formulation how we will explain. So later on, what happens? Schrödinger gave the Schrödinger just formulated this mechanics. Not only Schrödinger, actually, there are a number of scientists who just contributed one by one. And after near about 20 years, Schrödinger just developed this one, what we say, what we will be studying over here, that is wave mechanics. But before going into Schrödinger, the main thing is, after this Planck's hypothesis, there was a tussle between the scientists whether we will be going for this wave nature or whether we will be going for this particle nature. De Broglie was the scientist to solve this problem. So basically, if you just go through the development of quantum mechanics, যেটা অতি অবশ্যই তোদের পড়া উচিত because you are of CSE, সেটা এখন আমার পড়ানোর স্কোপ নেই, ঠিক আছে? তো আমি বলবো, আমি সাজেস্ট করব, ইউ শুড গো থ্রু দ্য ডেভেলপমেন্ট অফ কোয়ান্টাম মেকানিক্স, কি করে একটা করে ডেভেলপ হয়েছে। সেখানে কম্পটন এফেক্ট একটা জিনিস পাবি, গাইগার মুলার এক্সপেরিমেন্ট একটা জিনিস পাবি, উইল বি গেটিং সো মেনি থিংস, ওকে? I'm not going into details over here, but you should read it. Okay. So, Broglie, what happens? He just gave the relation, just gave the pathway relating this wave mechanics, wave nature, and particle nature. Before that, there was a tussle between the scientists whether we will be following wave nature or whether we will be following particle nature. Why this tussle was there? আমি এখনো ক্লাস শুরু করিনি, আমি এখনো বলে যাচ্ছি why this tussle was there. You should know the background actually, a little bit at least.
Because
yes, bol
particle exhibited both wave nature and particle nature. So there was a confusion of some cases it exhibited particle nature and in some cases it exhibited wave nature. So there was a
ঠিক আছে, সেটা গুড। আচ্ছা, তো আমি তোদেরকে ক্লাসে একটু বলেছি। অ্যাকচুয়ালি দ্য থিং ইজ, classical mechanics, if you are talking about classical mechanics, the particle nature and wave nature are separate entity. Hence, what happens is either you will go for particle nature or you will go for wave nature. Quantum mechanics shows, হ্যাঁ বল কি?
সেপারেট এন্টিটি মানেটা বুঝলাম না।
সেপারেট এন্টিটি, আলাদা জিনিস। ওকে, separate entity. As a result, you will be going with the particle nature or you will be going with the wave nature. But quantum mechanics says that particle nature and wave nature are not separate entities but complementary. If they are not separate entities, that means what? They go hand in hand. Okay, but they are complementary in nature. What do you mean by this? They are complementary means if you can observe in an experiment wave nature, you cannot observe the particle nature. Again, if you can observe the particle nature, you cannot observe the wave nature. That doesn't mean that if you are observing the particle nature, the wave nature is not there. No, the wave nature is there. But you are not able to observe both at the same time. Hence, they are going hand in hand, but they are complementary. Means you can observe only one type of nature. For that reason only, initially in classical mechanics, it was just these two are just taken as separate entities. So de Broglie gave the famous though. That is the significance, beauty of de Broglie hypothesis or de Broglie equation or relation. You have read de Broglie relation, but you haven't thought of what is the importance of this de Broglie relation. Okay, so this is the importance of de Broglie's relation actually. Okay, so what is the importance? He just related the particle nature and the wave nature. How we can say that one, or how he developed that development of this equation is very simple. He just thought that if you are talking about the orbit of radius A, this is the radius of the orbit A, and we are thinking that n number of waves are fitted in these orbits. N number of waves. So if n number of waves are don't be fool regarding this circle and this wave nature. Okay, this diagram just to make you understand. This diagram just to make you understand. Okay, so if there are n number of waves within this orbit, that means you can write 2 pi a equals to n lambda, since lambda is the wavelength, and if there are n number of waves, we can write 2 pi a is the perimeter of the orbit, 2 pi a equals to n lambda. And we have the Bohr's quantum conditions you have read, that is mva equals to nh cross. What is this h cross? H cross is h by 2 pi, right?
Yes, sir.
And what is the name of h cross? Reduced Planck constant. H cross is said to be reduced Planck constant. So linear momentum, this is the linear momentum. It is an integral multiple of h by 2 pi or h cross. That is the reduced Planck constant. So we have mva equals to nh cross. Now if you just replace a from these two equations, what happens is just find out the value of a from the first one and substitute in the second one. We will be having mv n lambda by 2 pi equals to nh cross, and if you just simplify this one, the value will be lambda equals to 2 pi h cross by mv. And since h cross is h by 2 pi, it is simply h by mv, and that is nothing but h by p. So this is the famous de Broglie relation, lambda equals to h by p. Think, lambda associated with a wave nature. P, momentum associated with a particle nature. So this relation is relating the wave nature and the particle nature, and obviously those are not two separate entities. They are complementary, but they go hand in hand. So this is the famous de Broglie wavelength, and from here we can write P equals to h by lambda, which can be rewritten as h by 2 pi into 2 pi by lambda. Okay. Now this 2 pi by lambda, h by 2 pi is h cross, we know, reduced Planck constant. This 2 pi by lambda, this we say to be wave vector, which is denoted by k. This is wave vector, which is denoted by k. So p, that is momentum, can be written as h cross k.
Sir,
Yes.
sir, I'm unable to see the screen. That what are you teaching?
Hai, বাকিরা সবাই দেখতে পাচ্ছিস?
না স্যার আপনার একটু স্লাইডটা চেঞ্জ করে দেবেন
না স্যার কিছু দেখতে
না স্যার ফার্স্ট পেজটাই আছে।
হ্যাঁ
তো ফার্স্ট পেজেই তো আছে, আমি তো অন্য কোথাও যাইনি। কি লেখা আছে বলতো? আঁকাটা দেখতে পাচ্ছিস?
শুধু
Quantum mechanics, first page.
আচ্ছা, হোল্ড অন। Is it visible?
Yes, sir.
Yes, sir.
And now it is visible.
Okay, so what I was talking about is of this slide. Okay, h cross is said to be, this is the first equation from where we are substituting a in the second one, and solving this one you are getting lambda equals to 2 pi h cross by mv, and finally lambda equals to h by p. If you rewrite this one, p equals to h by lambda, that is h by 2 pi into 2 pi by lambda, and that is equals to h cross k. So the momentum can also be written as h cross k. This is a very important relation, and we require this one when we will be doing the স্নেহা হাজরা আছিস তো? স্নেহা
স্যার
বলো স্যার।
স্যার বলছি আমার একটু নেটের প্রবলেম হচ্ছে, আমি স্যার গ্রুপ থেকে এই লেফট হয়ে তারপর জয়েন হচ্ছি।
আচ্ছা ঠিক আছে,
স্যার একটুখানি দাঁড়ান।
ঠিক আছে, গেলে আবার জয়েন করবি, the same ID and same password. Okay, so this is the thing, p equals to h cross lambda, which is very important relation. We require this relation, and this 2 pi by lambda, if you can see this 2 pi by lambda, this we are writing as k. H by 2 pi is h cross and 2 pi by lambda is k. So p can be written as h cross k. This k is said to be the wave vector. Again, if you are talking about that an electron, say for example, an electron is acquiring a velocity of v through a potential difference of capital V volt, then obviously its kinetic energy can be equated with EV, where E is the electronic charge and V is the voltage. And hence, you can write V equals to 2E capital V by m naught, where m naught is the rest mass of the electron. Now, if you substitute this value of V in this equation, lambda equals to h by mv, what you are getting is lambda equals to h by root over of 2e capital Vm. So whenever an electron is, or whatever, if we are talking about electron, we can talk about some charge particle also. Say for electron, for example, is passing through a potential difference of V volt, and it is acquiring a velocity of v, then obviously the lambda, that is the de Broglie wavelength of that electron, will be this much. In this equation, actually H is constant, E is constant, M naught is also constant. H is constant, E is constant, M naught is also constant. So if you put all the values of constant, what happened is you will get a value, and which is 12.27. In angstrom, it is lambda equals to 12.27 by root V volts. Okay, clear? Understood?
স্যার এই p ইকুয়ালস টু যে h বাই 2 পাই ক্রস 2 পাই বাই ল্যামডা এইটা বুঝলাম না।
h by lambda টাকে লিখছি h by 2 pi into 2 pi by lambda। এখানে 2 pi কেটে গেলে h by lambda হয় তো, সেই h by lambda টাকে লিখছি h by 2 pi into 2 pi by lambda। h by 2 pi কে লিখি আমরা h cross, আর 2 pi by lambda কে আমরা লিখছি k। k হচ্ছে ওয়েভ ভেক্টর।
আচ্ছা আচ্ছা,
p equals to h cross k। বুঝাতে পারলাম? ক্লিয়ার?
হ্যাঁ হ্যাঁ।
আচ্ছা, দেখা যাচ্ছে? An electron falls through a potential difference.
হ্যাঁ
হ্যাঁ
স্যার
স্যার।
Okay,
Yes, sir.
so an electron falls through a potential difference of 100 volts. Okay, what you have to calculate is the momentum of the electron and the wavelength associated with the electron. এটা ক্লাসে করিয়েছি জানতে বলছি। And how could these waves be detected? How could these waves be detected? Say we are talking about the velocity. We know velocity v equals to root over of 2e v by m naught. We know the value of e, we know the value of m naught, we know the value of v is given 100 volts. So p equals to m naught v. Momentum p equals to m naught v. If you put the value of v, then we are getting root over of e capital V m naught. So all the parameters are known to you. You just put the parameters, solve it, you get the values. And the value of p is this much. And if you know the value of what is the de Broglie wavelength, lambda equals to h by p, put it, you will get the answer, which is 1.226 angstrom. Simple problem. Is it clear? Understood?
Yes, sir.
The thing is, you should know the spectrum, electromagnetic spectrum, for answering this one. How could these waves be detected? If you just look at this one, 1.226 angstrom, this actually falls in the X-ray range. So, if it falls in an X-ray range, how these X-ray are detected? By the diffraction of crystal. So that means how could these waves be? By the diffraction of crystal. Diffraction of crystal means, I will be teaching you solid state over there. You will see Bragg's law. I will be just showing you the Bragg's law. 2d sin theta equals to n lambda. That is the diffraction of crystal. Okay, clear? Understood? বোঝা গেল?
হ্যাঁ স্যার।
Okay. This type of problem can be extended. Extension of the previous problem. What happens is you have to find out angle of incidence. You have to find out angle of incidence. This is the Bragg's equation. Okay, 2d sin theta equals to n lambda. Just for the time being, remember this. Solid state যেদিন পড়াবো সেদিন আমি বলে দেবো। I will let you know. Okay, 2d sin theta equals to n lambda. So 2d sin theta equals to n lambda is the Bragg's equation. Actually, we find out the glancing angle or the incidence angle. The angle of incidence is also called the glancing angle theta. You have to find out this one. This is the extension of the previous problem. How? Using this one, using value of lambda from here, you have to calculate this. And this d value will be given to you. is the interpinner spacing is 2.15 into 10 to the power minus 10 meter. This will be supplied. Okay. And n is already given in the sum. First order reflection. So n denotes order of reflection. First order reflection means 1. N equals to 1. Lambda you got from the previous one. So if you put the values, you get sine theta equals to this much. That means theta equals to 16.60. So if those rays are falling on atomic planes, those are reflected. And we first order diffraction pattern is treated as reflection. And since we are getting first order diffraction pattern, we can find out what angle these rays are falling on these atomic planes. This is a problem of solid state physics. Initial part is a problem of quantum mechanics. So there can be a problem consisting of two parts. Is this clear? Any question? Anything you want to ask? জিজ্ঞেস করার আছে কিছু? ওকে, নেই। এক মিনিট আছে, শেষ করতে পারবো না। জয়েন as fast as possible. Join as fast as possible.
স্যার স্যার
হ্যাঁ বল।
বলছি আমি বারবার জয়েন হচ্ছে কিন্তু আমি বারবার জয়েন হচ্ছে বাট অটোমেটিকলি বারবার বের হয়ে যাচ্ছি।
বারবার জয়েন হচ্ছে, যেটা নেটওয়ার্কের প্রবলেম হচ্ছে। একটু নেটওয়ার্কটা ঠিকঠাক জায়গায় থাক। অর্ঘ, ক্লাসটা কর বাবা, গান পরে গাইবি। হ্যাঁ, রোশনি এসছে?
Yes, sir.
রোশনি আর তিথি একটুখানি পার্টিসিপেন্ট লিস্টটা খেয়াল রাখিস। তোদেরকে কোহোস্ট করে রাখলাম। আচ্ছা, Okay, so visible, I think, right?
Yes, sir.
Okay. Next, we will come to Heisenberg uncertainty principle. If I ask you the Heisenberg uncertainty principle, what happens is you will be stating this one: delta x delta px greater than equals to h cross by 2. এখানে কেন h cross লেখা পরে বলছি, কি বলবো মন দিয়ে শুনবি। That is actually not the general statement of Heisenberg uncertainty principle. You have to write Heisenberg uncertainty principle in general. And what is that one? It is impossible to mention accurately and simultaneously the values of both the members of a particular pairs of physical quantities that dictate the behavior of an atomic system. What do you mean by this one? If you're talking about, say, what you read till date, x and px, obviously, keep it in mind, not x and p. If you're talking about x, then corresponding momentum means momentum along x-axis, that is p suffix x. If you are talking about y, then y and py. If you are talking about z, then y and pz. এরকম নয় যে only we are talking about x and px. We can talk about y and py also. So the pair which are dictating the behavior of the atomic system, pair means these pair, that is momentum, position and corresponding momentum. Even if you are talking about angular position and component of angular momentum. Okay, even if you are talking about energy and time, these are the pairs which dictate the atomic behavior, dictate the behavior of the atomic system. And if you are talking about this pair, you cannot mention accurately and simultaneously values of both the pairs, means both the parameters. So that is the general statement. Now, if you just think of the mathematics, what you say? You cannot measure momentum and position simultaneously, isn't it? In this way, you say. So that will be the definition till class 12. Now the definition will change, should change. So it is impossible to mention accurately and simultaneously the values of both members of a particular pairs of physical quantities that dictate the behavior of an atomic system. Is this clear? Understood? And you can also say, if you want to derive the mathematical formulation, you can also say order of magnitude of the product of uncertainties in the values of these two conjugate quantities must be at least equal to reduced Planck constant. So this is the mathematical term and this is the physical one. So from this statement, you can mathematically derive that delta x into delta px greater than equals to h cross. Now you can say, sir, আমরা তো h cross by 2 পড়েছিলাম, তাহলে আপনি h cross বলছেন। Actually, when you will be deriving all those things, it should be in terms of h cross, okay? Because this is the general statement, but still, in doing the sums, we generally use this h cross by 2 in some cases. Well, we said, তাহলে পরীক্ষার সময় কি করব? h cross করব না h cross by 2 করব? What we will do? Obviously, if you are proving something, then you take h cross, and if you are doing some sums, any numerical, then you take h cross by 2. But why there will be a difference in h cross and h cross by 2? Actually, if you think of h cross or h cross by 2, what is the order of the order? What is the order? Whether you take h cross or h cross by 2? 10 to the power minus 34, very small. The order will not change. If you are talking about h cross or h cross by 2, the order will not change. So if you are going through quantum mechanics books, say 15 to 20 books, you will find that in some books it is written h cross and in some books it is written h cross by 2. that makes no difference. But when you are proving something, obviously you will go for H cross. Is this clear regarding this Heisenberg uncertainty principle? Any question you want to ask? Any question you want to ask? Anything? কিছু জিজ্ঞেস করার আছে? Any question? বোঝা গেছে? Have you understood?
হ্যাঁ স্যার বুঝি।
Yes, sir.
Okay, fine. So, if you go through this one, this is a proof that there are no free electrons in the atomic nucleus. Okay? We are talking about free electrons. Keep it in mind. We are not talking only electrons, because if we are thinking of a radioactive substance, then obviously if beta particles comes out, the charge of beta particles are negative, and those are assumed to be electrons. That is a transformation of this neutron and proton. Okay? So, but that is not free. Just keep it in mind. We are talking about free electrons. And we know in an atom, free electrons are always outside the nucleus, revolving around the nucleus. And you can prove it. How? Using this Heisenberg uncertainty principle. If you are talking about the dimension of this atomic radius, actually, so rather the order of this atomic radius is 10 to the power minus 14 meter. So roughly, if you assume this one to be the radius of this nucleus, then the diameter will be 2 into 10 to the power minus 14. This can be the maximum uncertainty in position. Why I am saying so? This can be the maximum uncertainty in position, because the electron, we are assuming electron within the nucleus. We are assuming the electron within the nucleus. So that means the maximum uncertainty can be this diameter. If we are talking about more than this diameter, that means the electron is outside the nucleus. So if we are assuming that a free electron is residing within the nucleus, that means the maximum uncertainty in position. Maximum uncertainty in position will be how much? Will be the diameter of this nucleus. Is this clear?
হ্যাঁ এটা স্যার আবার বলে দিন।
হ্যাঁ,
না স্যার একবার বলুন।
কি বলবো বল? কি বুঝিসনি সেটা আমাকে বুঝতে দে। কি বুঝলি না বল আমাকে, কি বুঝলি না আমাকে বল। আমাকে তো বুঝতে হবে সেটা, যে কি বুঝতে পারলি না। কে জিজ্ঞেস করলি? দেখো চুপ করে আছে। শোন, লজ্জা পেয়ে কোনো লাভ নেই। যেটা বুঝতে পারিসনি সেটা বলবি না, আমাকে তো জানতে হবে কি বুঝলি না। সেই পয়েন্ট।
হ্যালো স্যার,
হ্যাঁ বল পল্লব, বল।
এটা স্যার কি বললেন সেটাই বুঝতে পারিনি, একটু শুনতেই পাইনি আমি একটা।
আচ্ছা, শুনতে পারিস না। We are talking about that an electron is within the nucleus. What can be the maximum uncertainty? सबसे बेशी uncertainty की कत होते पारे? इतना maximum uncertainty हो सकता है। Obviously, उसका जो diameter है, वही maximum uncertainty in position हो सकता है, isn't it? The diameter can be the maximum uncertainty in position. Maximum uncertainty in position. তার থেকে তো বেশি আর হতে পারে না, because if it is more than the diameter, that means the electron can be outside the nucleus. That is not the case. Is this clear?
Diameter was the whole diameter.
Diameter can be the maximum uncertainty in position, isn't it?
Yes, sir.
If that is so, then whenever we are talking about this Heisenberg uncertainty principle, then if we are finding out the maximum uncertainty of one parameter, that gives us minimum uncertainty in the other parameter. Gives us minimum uncertainty in the other parameter. So that means if delta x is the maximum uncertainty, that will be the maximum uncertainty, that is the diameter, which is this much, and this gives us minimum uncertainty in position, momentum, using the Heisenberg uncertainty principle. See, we are doing a proof. We are not using h cross by 2. We are using h cross. So delta p equals to h cross by delta x, and accordingly we will get the value of delta p, that is the minimum uncertainty in momentum. So if this is the minimum uncertainty in momentum, that means this can be the minimum momentum. एर थेके कम, इससे कम momentum नहीं हो सकता, होबे ना. This is the minimum momentum. So if we are getting this value to be the minimum momentum, so minimum momentum obviously is contributing to the minimum energy. So we can find out the minimum energy, but here we have to take into account relativistic energy. এই equationটা মুখস্থ রাখতে হবে. Here we have to take into account relativistic energy, not this using this kinetic energy equals to half mv square or p square by 2m. No. We are using the relativistic energy, which is E square equals to P square C square plus M naught square C to the power 4. E square equals to P square C square plus M naught square C to the power 4. So, C is the velocity of light, M naught is the rest mass of electron, and P is the minimum momentum, response to the minimum energy. And putting all these values, the minimum energy comes out to be 1.58 into 10 to the power minus 12 joule. Converting that one into electron volt, we get 9.88 mega electron volt. So if an electron is within the nucleus, its minimum energy should be 9.88 mega electron volt. But the kinetic energy of maximum kinetic energy of a beta particle is 4 mega electron volt. So that means an electron, free electron, cannot exist within the nucleus. Other way around, we are proving. Is this clear? Is this clear?
Can you please repeat the last part?
Last part, have you understood how we are finding out the E mean, this value?
Yes, sir. So about the kinetic energy.
So this is the energy of an electron which we are assuming within the nucleus. This is the minimum energy. But whenever we are talking about radioactivity, beta particle is coming out. Beta particle is negatively charged, right? We consider those to be electrons, and maximum kinetic energy of a beta particle can be 4 mega electron volt. So that means if an electron is residing, free electrons is residing within the nucleus, that would have a minimum energy of this 4 mega electron volt, but that is not the case. It has a minimum energy of 9.88, roughly 10 mega electron volt. So can a free electron exist within the nucleus? Obviously no. Because if it has to exist within the nucleus, its energy should be less than the beta particle. Minimum energy, but it has a minimum energy which is higher than the maximum kinetic energy of the beta particle. So it cannot reside within the nucleus. Understood?
Yes, sir.
Okay. Next, we are just moving on. This is a numerical. An electron has a speed of 500 meter per second. The speed is given. with an accuracy of 0.05%. I will be giving you many terms. Okay. Just give me 2-3 days. I will be giving you. So, with the accuracy, বুঝতে পারলাম না বল কি
বলছি এখানে অ্যাকিউরেসিটা মানে কিসের অ্যাকিউরেসি বোঝা
with an বলছি দাঁড়া with an accuracy of 0.005%. Accuracy in speed. That means this is the uncertainty. Calculate the uncertainty in position. If you have to calculate the uncertainty in position, first calculate the uncertainty in V. And delta V equals to 0.005% of V. V is given 500, and if you just find it out, you get the value of delta V, which is 0.025 meter per second. If you know delta V, obviously you can find out this delta X, because delta P, the value of delta P is, since P equals to mv, delta P equals to m into delta V. Okay, just use this one. এখানে যে করা আছে সেটা h/2 দিয়ে করা আছে, আমি তোদের বলে দিচ্ছি, I am just telling you, use h/4 and calculate. এটা h/4 calculate করলে এটার half value পাবে, 2.305 millimeter will be the answer of delta X. Simple problem. Clear? Any question?
না স্যার
Okay. So if we move on again, one more sum. Velocity of an electron, here also it has been calculated using h cross. Okay. But whenever I am telling you, whenever you will be solving, okay, you will use h cross by 2. Solving numericals. ঠিক আছে? The velocity of an electron and that of a rifle bullet of mass 30 gram are measured, each with an uncertainty of delta Vx equals to this much. So uncertainty is already given, uncertainty in velocity. Okay, of an electron and of this rifle bullet of 30 gram mass. We have to find out the uncertainty in position. Very simple, delta X will be h cross by m into delta Vx. So I want to tell you this thing. If you know the value of Planck constant, you should know the value of reduced Planck constant. Knowing value of reduced Planck constant, which is 1.054 into 10 to the power minus 34, you can directly use it. Or else you have to put the value of Planck constant, divide by 2 pi again. Remember the value of reduced Planck constant also. Okay, 6.626 into 10 to the power minus 34 joules again. That is a Planck constant. 1.054 into 10 to the power minus 34 joules again. That is for reduced Planck constant. So if you know the value, directly you put the value and you get the value of delta X for electron, which is coming to be 0.116 meter. And the delta X for the rifle bullet of 30 gram mass, which is coming to be 3.5 into 10 to the power minus 30 meter. Just look at the difference. Even if you take a mass of 1 nanogram, value of uncertainty, using this value, the value of uncertainty in position will be of the order of 10 to the power minus 22 to 25. Very, very less. For that reason only, for massive object, we cannot understand. For massive object, we cannot understand the uncertainty. Uncertainty plays a crucial role in atomic or subatomic particles. But for massive object, it simply falls into the limit of these experiments. We simply cannot understand the uncertainty for massive objects. Is this clear to you?
Yes, sir.
Any question you want to ask? Anything? কিছু জিজ্ঞেস করার থাকলে আমাকে জিজ্ঞেস করতে পারো। Any question, anything. Okay, fine. Kono question নেই then. Okay, we can move on. Hold on. আর একটুখানি আমি বলবো। Is it visible?
Yes,
Yes,
sir.
Okay. So we will start a little bit of wave function and Schrodinger equation, which I will try to complete by tomorrow. Okay. If you think of classical mechanics and quantum mechanics, actually, there are so many differences. Okay. Already, while I started teaching you this quantum mechanics, whether in class or today now, in this class, I've already discussed this difference a little bit, but you didn't catch up this one. Okay.